In traditional blast furnace, sinter, pellets, and coke form the backbone of iron making. HyCROF retain these but innovates by injecting pulverized coal at lower levels. This is not just a tweak, it's a strategic shift. Globally, steelmakers like POSCO and ArcelorMittal are exploring similar injection techniques to reduce coke rates and improve combustion control. The PC injection in HyCROF provides a flexible carbon source, enabling better thermal profile and reducing reliance on high-grade metallurgical coke, which is both expensive and carbon intensive. Cold oxygen injection is here is having a main role. Here's where HyCROF break convention. Instead of preheated air, it inject cold oxygen at 2 level. This create a high oxidation zone that ignite coke and PC more efficiently, generating intense localized heat and CO rich reducing gas. This method also explored by Nippon Steel in Japan allows for precise control of combustion and minimizes nitrogen dilution, boosting furnace efficiency. It's a leap towards oxygen steelmaking in blast furnace domain. Preheating of reducing gas is having a tremendous role in this process. That is, preheating the reducing gas before it enters the furnace is like giving the reaction a head start. This step enhances thermal efficiency and reduces the burden on coke combustion as it carries more sensible heat with it. In Europe, similar strategies are used in MIDRX and HYL direct reduction processes. HyCROF adapts this to the blast furnace, improving gas solid reaction kinetics and enabling smoother reduction at lower coke rates. It's a smart fusion of blast furnace robustness and DRI fineness. Top gas recycling is a game changer. Instead of venting CO and hydrogen rich exhaust, HyCROF capture and reuse it. This mirrors the approach of the ULCOS project in Europe, which demonstrated up to a 50% CO2 reduction using TGR method. Already we have a dedicated TGR a module in this presentation. You can refer to this for better knowledge sharing on TGR. By looping back these gases, HyCROF not only conserve energy but also slashes fresh reductant demand. It's circular chemistry in action, we can say. The turning waste into fuel. Before recycled gas re-enter the furnace, CO2 is scrubbed out. This is on the similar method of TGR where BPSA absorb carbon dioxide and make the top gas refined, filtered out all CO2 absolute term, so that the entering gases has a both reducing component, that is CO and hydrogen. So we can say that before recycle again, we repeat that before uh, recycled gas re-enters the furnace, CO2 is scrubbed out. This step purifies the gas stream and enable carbon capture. Globally, CCU is gaining traction. Norway's Northern Lights project and the US Petra Nova plant are leading example. HyCROF integrate into the iron making flow making it not just a steel process but a carbon management system. The captured CO2 can be stored or reused in chemical fuels or even concrete. हो गया मोना टेढ़ा हम तो जानबूझ के रखे हैं ना